Three solutions, degree is 3, and I have to find 3 solutions. Can anyone tell us when is this 0? So let's write it, negative x squared, 4x minus 3 equals 0. And we have 3 solutions. Can anyone give any?
Is one of them 0?
Yes, 2 of them, right? Because this is x times x, so 2 of them are 0. Perfect. And what about the other one?
3/4.
Yes. So I have 4x minus 3 equals 0. I move 3 divided by 4, so I get 3/4. These have to be put in the table if they fit. What does that mean? What if I have a solution x equals 7? There is no place to put it in. It may be a critical number, but not in the given interval. Okay? So I will put them in only if they fit in the given closed interval. Okay. So then 0 is in the table, and f prime is 0. 3/4 is smaller than 1, so it's in the table, and it's right here. At this point, I have to study the sign of the derivative. And at the same time, for a closed interval, I have to find this number, also this number here for the function, this number here for 3/4, for 0, and this number here. And then decide what goes where and what they mean. So first I'm going to put in the graphing calculator, I'm going to put the derivative. There is no need really, because what type of number is x squared? Always just x squared.
Positive.
That's it. So it's gone. Can you plug in a number like -1 in here, keeping in mind that there is a negative in front, and tell me the sign? So I plug in -1, perform the calculations, and only tell me the sign. I don't need any number.
Positive.
Perfect, because this is negative times negative. Good. So now here I have to be careful, right? Because I need a number between 0 and 3/4, like 0.5 or 1/2, or maybe 1/4. 4 times 1/4 is 1. 1 minus 3 is -2. -2 times a negative number is still positive. And now plug in 1 and tell me the sign. Just the sign.
Negative.
Yes. Perfect. Now I will put this function in the graphing calculator, and I will plug in 4 numbers. -1 for x values. -1, 0, 3/4, and 1. So I'm sharing my screen. Go to the calculator, and y equals, clear whatever you have. Okay, so the function was x cubed, and then minus x to the 4th. And then in the table, I will plug in sequentially, then -1, and then 0, and then 3/4, or 0.75, and 1. I copy these values in my table, and let's see what I got. I got -2, I got 0, I got 0.11, and the last one I got 0 again at 1.
I have a question.
Yes?
For the calculator, how did you get it so you can do the custom values again?
With second and table, make sure that the independent, just the independent, is in a ask mode.
Okay.
And then you have, it allows you to put the custom made whatever you want. Good?
Okay, thank you.
Thank you. So now we're going to make our decision. From -2 to 0, what does the function do?
Decrease.
Increase.
Or increase.
Yes.
Increase.
And that's supported by the sign of the derivative. From 0 to 0.11, what does the function do?
Increase.
Yes, and that's supported by the sign. And now from 0.11 to 0, what does the function do?
Decrease.
Good, which is supported by the sign of the first derivative. So these two rows work well together. And now we have to make a decision. Remember what we said, and I'll come back for us in a second. Remember what we said about this function. This is on a closed interval. It starts here and it stops here. There is no error. So it starts at a particular point and it ends at a particular point. So because here I cannot show the open interval, this cannot be a relative. This one is a relative max because the function exists on both sides and all function values are smaller than that one. Same thing here. It is a relative min because I can show the function and the function values are bigger than this one. But here, this and this, in my example, cannot be relative. Since this is the absolute largest, I'm going to say absolute max. Since this is the absolute minimum, I'm just going to say this is the absolute min. So please remember no relative or local at the endpoints of the interval because the function does not exist on this side. Same thing here, never relative. So now let's analyze. So this function, just imagine it starts at -2, it goes up to 0, further up to 0.11, and then it comes back to 0. Notice that there is no sign change here. So this cannot be a local max or local min because there is no sign change of the derivative. Here there is a sign change, positive and negative. So what type of point is 3/4, 0.11?
Local max.
Local max or relative max? Local max. Good. So now this is the local max. This is nothing. This is nothing because it's not the largest, it's not the lowest, and it's at the endpoint of the interval. This is also 0. Nothing, nothing. A relative max, local max, also absolute max. There is nothing higher than it. This is the highest, 0.11. What about this point? What will this point represent? It cannot be local. It can only be an absolute. Is it an absolute? Any questions? Any ideas?
Is it absolute min?
Exactly. This is indeed the absolute min. So the point -1, -2 is the absolute min. Nothing because there is no sign change. Relative or local as well as absolute because there is nothing higher than it. Nothing. It cannot be local because it's at the endpoint of the interval. It's not the highest and it's not the lowest. This is how we study or find max min on a closed interval.
Like a question.
Yes?
So you're saying that 3/4, 0.11 would
Yes.
be the absolute max as well?
Yes. Yes. The
Okay.
absolute max and the local max because I can show the function. The function exists on both sides. So this is the absolute max, the relative or local max as well because the function exists on both sides. Good. Other questions? Good. So now that's all there is to studying the function on a closed interval. I'd like us to look at some word problems. Where is my book? Here. Again, we can work on any other function. All we have to do is find the derivative, find a critical number, and then plug in the function all critical numbers and the end points of the interval. I'll let you choose if you think we have to look at another. If not, I'd like to look at a word problem.
Which ones are we choosing from?
Anything you want, 17 through. These are also possible. They get more and more intense, as you see. You can choose from here as well.
Can we do like a simple exponential one? Maybe?
Yes, yes. There is no simple exponential, but absolutely yes.
Huh.
So yeah, the problems in this book are not simple. So what about choosing from 37 or 38? Is that what you had in mind?
I was thinking like up.
Up it is.
Yeah.
Yes, of
Yeah,
course.
Like
Anything.
one of those maybe.
Yeah, please
Maybe like
choose.
23 or something.
Okay, 23 is good. So we have f of x equals e to 3x minus e to 2x, and we have negative 2 comma 1. Good. Okay, perfect. So we know what we have to do is the same question. Find the absolute, relative, everything, max, min. Nothing else. Don't graph. Just find the points and explain what they mean. That's all. The interval is given to us. There is no discussion there. That saves time. We don't have to find domain or anything. The domain will be everything anyway. I go directly to f prime. E to 3x prime is e to 3x times the inner function prime minus e to 2x times the inner function prime. This is that thing that we did last time. So f prime of x equals 0. I have 3e to 3x minus 2e to 2x equals 0. We have to divide both sides by one or the other. It doesn't matter. I'm just going to choose e to 2x. That's the better of the two. Good. So 3 e to 3x divided by e to 2x. Can anyone tell us what does this mean? How much is this? E to 3x divided by e to 2x. E to which power? That's it. 3x minus 2x is x. So e to the x, and then negative 2 divide e to the 2x divided by e to 2x is just negative 2. Exactly how we did last time. I move 2 divided by 3. So I have e to the x equals 2/3. Now what type of equation is this and how do I solve it? And we reviewed this in chapter 2. So what operator I have to apply to both sides?
Natural log.
Natural log. Natural log to both sides. X, because natural log e is 1, x equals natural log 2/3. Of course, I have to approximate this. If you tell me what is natural log of 2/3, I have no clue. So I expect a negative number, but how do I know what the number is? So natural log of 2 divided by 3, because it's a number less than 1, so it has to be a negative number. But how much? I have no idea. Okay, so negative 0.41. Negative 0.41. Okay, fine. I go back to my table immediately. Is negative 0.41 here? Yes, it is. 0 here. And now I need to study the sign left and right. I'll plug in the function in the graphing calculator. Which function? 3 e to 3x minus 2 e to 2x. Plug in negative 2, plug in 1, and have the sign. I don't need the numbers, I just need the sign. This is more difficult to plug in. That's why I will put it in. I can't say it's positive or negative. No, I can't do that. So I'm sharing my screen. So in y equals, I clear, and I have 3 e to 3x minus 2 e to 2x. Good, so I will plug in the derivative. I plug in -2, see what I get. And I plug in 1, see what I get. So it's negative and positive. Now I have to plug in the calculator the original function to determine this number here, this number here, and this number here. And according to this, the function should decrease and should increase. If not, there is an error somewhere and I have to go back. Okay, so in y equals, since I'm not going to use this again, I'm just going to do this like lazy people. I didn't mean to do that. I meant to just erase the 2 and the 3. Never mind. That's what I said. Lazy. 3x. I used the wrong delete. That's what happened. But that's okay. It's not a big deal. So e to the x to 2x. And close. That's the original function. And I need 3 values in it. I need the -2. And I'm going to copy it, -0.016. At 1, I'm going to copy 12.7. And I also need -0.41. So yeah, look at that, -0.15. Good. So now I have to make sure that my numbers match the signs of the derivative. From this to this, yes, that's true. This is a larger number than this. That's correct. Now from this to this, it's perfect. So now imagine what we have. We have -0.16, 0.16. We have -0.15, and we have 12.7. This is not the graph of the function. I'm just picturing those numbers so we can make a decision quickly. So what type of point is this? -2, -0.016.
Absolute mean?
So this is the absolute min, right? Because it's coming from above, coming to -0.15 and going to 12.7, right? So this is the absolute min and relative min. That's right here. What type of point is this one? -2, -0.
It's just nothing.
Nothing. Thank you very much. It's at the endpoint of the interval. It's not the smallest, it's not the largest. It can only be absolute because it's at the endpoint of the interval. This is in the middle. This is the absolute min because it's the smallest and also a relative min. What about this point? 1, 12.7. It cannot be a relative because it's at the endpoint of the interval. It can only be an absolute max or an absolute min, or nothing.
Is it a max?
Absolute max.
Absolute.
Yes, it's the largest possible value on this interval.